Nope. Nobody's commented on this. I am not going to.
Yeah, so I'm at this.
All right, it's time to get this party started. Hello and welcome to the TLS session number 2 at IETF 104. Our chairs, Chris Wood, Joe Salloway, and myself, Sean Turner. This is the Note Well. You should have seen it a couple times by now. What? Oh, closer. Okay, I can do that too. This is the Note Well. Super loud up here. But anyway, basically, if you get to the microphone, you're going to get recorded. There's video in here. If you get IPR, you're supposed to disclose it. Don't be a bad person. You can read the rules. Next. Requests. We need a minute taker and a jabber scribe before we proceed. Who's willing? Rich. Rich did jabber. All right, great. Wendy, you can back him up if you want. Okay. Minute taker?
Note taker.
All you got to do is say what the outcome was. We don't need minute by minute. Who? Oh, okay. I think someone's phone's going to blow up in a second. Richard's going to do it. Thank you very much, sir. When you get to the microphone, please state your name. Let's keep it professional and let's keep it succinct too, because we have a lot of presentations today. Next. That was the first day. The next day. So this is the administrative part, and we got a whole lot of presentations. The ones between the two lines are working group drafts, and the ones at the end are not. We did have another non-working group draft called CTLS for Compact TLS, but we agenda bashed it off. It's out there, so you can go read it, but it wasn't really ready for prime time. And without further ado, is there anything else we want to talk about before turning it over to deprecating TLS 1? And nope. All right, let's do it. So I think it's Kathleen. Yep. Make sure to knock that water bottle directly on your.
Yeah, it's not mine. It'll be okay.
Hi, so we're just here to give, Stephen's in the audience, so we're here to give a little update on deprecating TLS 1011. We think we're pretty close to done and just want some finalizing feedback. And so there were a few updates made since the last meeting. It's all on the list, and so I'm just going to review the ones that we did resolve, but are open to additional feedback if there is feedback, so please provide it if necessary. Oh, it's right in front of me. Let's see, so 8261 has text about DTLS implementations supporting 1.0, and so a result of this conversation was, should we be more explicit about DTLS 1.0 deprecation in light of this work being recent. And the work in this case is that I believe it recommends DTLS 1.2, but doesn't do a hard deprecation. And so the update made was in the abstract here to add mention of DTLS 1.0. So are there objections to that update? Do people need time to look at this? No objections. Fantastic. Huh? Did I miss something?
Hi, Stephen Farrell. I just didn't understand what that means. So we currently don't have an updates 8261, and I have no idea if we should or not. I don't really care.
Yeah, I don't.
Okay, I thought the point was actually adding the DTLS 1.0 text, and that was the question from the list, traffic, as opposed to updates 8621.
So, I mean, DTLS 1.0 is no better than TLS 1.1. Being more widely used because there's no DTLS, because DTLS 1.0 is TLS 1.1. So being more widely used because there's no 1.0 to match. But I think we should still tell people to stop using it and start using DTLS 1.2.
So add it to the updates list.
I'm unable to process that process issue, but it sounds like it. Yeah.
Okay, thank you.
I mean, the only point I would add is that obviously this was not one of our documents, so we should, make sure that we tell them before IETF last call that we've done this, right? Isn't 8261? Am I looking at the right one where it's DTLS encapsulation of SCTP packets is done by the transport area? Or was it AD sponsored? Yeah. So I'm just saying another process thing. Just tell them, hey, we're doing this, so that we have the firefight now and not later.
Okay.
That's it.
Well, just a question there on that, John. This thing updates like 70 or 80 different RFCs.
That's great. I love that process.
But isn't IETF last call enough? Because
maybe it is. Yeah. I mean, I'll send them an email and we'll see.
I'll write a script email. Could do. But half the mails will bounce.
Yeah. Okay.
Okay. So the next question discussed on the list was about NNTP and some should not and must not language for using, I think it was 1.0 in this case. And the response Stephen gave on list was that it was good to do this update because should not and must not are not the same things, right? So we are deprecating its usage. And so this makes it a little more clear by doing that update. Does anyone have a problem with that? Okay, wonderful. A reference for 3GPP deprecating TLS 10 and 11 was updated. And then, so I think at the last meeting, I'm pretty sure Stephen already went through the 70 different documents that this updates. And these are just some notes on additional updates to other documents. I don't think there's anything here to really comment on, but it's here in case there's something that you feel is important to comment on before we move along. And we'd like to know if we think this is ready for working group last call.
So to be explicit, we're looking for violent objections.
Thank you.
Violent support, perhaps, Martin Thompson. I dropped a link to our current stats on where things are at in terms of turning this off for the web into the Jabber. If anyone's interested, they should take a look at that. It's pretty bad. There's a lot of sites out there that still don't support TLS 1.2. I don't mind that people accept TLS 1.0, but not supporting TLS 1.2 is kind of bad in this situation, and that's really what we're pushing for here by deprecating 1.0 and 1.1. So.
Right, and what I've been saying to people who asked is like OpenSSL said they would support for 5 more years, so you do have transition time even after this is published.
Yeah. All right. So I'm seeing no violent objection. We'll get that started when we get back to our respective homes. And thank you for perfect timing, Kathleen. All right, next. DTLS, is that Hannes? Nope. Becker?
All right. This may be even shorter. So I can remember what that guy said. So I just pressed a 31 draft, literally like, I think yesterday. I was doing other things before the meeting. This has basically a bunch of editorial improvements, thanks to Martin especially. The examples had sort of an annoying bug with the bits that were in the original order instead of the new order. The new order is better, but the original order is confusing, so I fixed that. So actually, I fixed it twice. Martin fixed it, then I fixed it. So hopefully people will find it easier to implement now. Can we take a look at the example? There are a small number of open issues raised in the last call. I think maybe all by Martin. The first one of these, issue 78, DTLS has sort of a fuzzy kind of attitude towards amplification. So quick, like there's a lot of effort and says basically like the client hello has to be a certain minimum size, and well the initial, but it's actually client hello in this case, and that you're only allowed to send end packets in response. DTLS has been like historically kind of vague on this, and like said has this this path validation mechanism used to be called hello verify request, now it's called hello retry request, but you're not required to do it, you're just kind of like encouraged to do it. There's some scenarios where this isn't any kind of issue, so especially so probably like one of the most common DTLS scenarios is doing WebRTC, and then you've already done ICE, so you have confirmation of receipt. Question: should we do something here? Something, not something. I guess I'm sort of like not enthusiastic about doing a lot of things here. The major reason this is an issue is if you have like a server which is like serving a lot of traffic and therefore is a DOS amplifier and also has and also has like a big response and also is basically doing 0 RTT or has like a giant certificate, and like none of these things seem like super valuable. If people wanted to have a quick type thing, I'm like not gonna like be completely objected to it, but I think probably just like say you should do HRR in sensitive cases where you're likely to be an amplifier is good enough. Martin, are you gonna object to this?
So I think the advice can be a little more than that, but sorry, Martin Thompson. The advice we have in Quick is basically don't send significantly more than what you've received from this apparent address. And so in the 0 RTT case, there's this huge potential for amplification. Right. If you're not careful, simply say don't do that unless you've validated that the other side would be fine. I think you probably want to have a must level requirement in here. I know it gets a little fuzzy in certain deployment scenarios, but a must level with some number for amplification would probably be better than a
right. So like no more than 10x without or some other independent path check.
Right. Yeah, I think that's probably the right way to thread this particular needle. Obviously, once you have ICE, then you have the path check.
You can make you want.
It's not a big problem. So most deployments won't have this problem. But once we have 0 RTT, I think there's a genuine problem here to address. So we should at least address it somehow.
Hi, this is Hannes. The only environment where we have seen DDoS attacks in the IoT context was when CoAP was used without DTLS. Actually, we had not seen any amplification attacks based on the use of DTLS. And specifically, thinking about 1.3, there's also the pre-shared secret-based mechanism where there's actually no need then to use the the hello retry request, because you're already authenticating the client on the first packet anyway.
Well, you don't know the IP address though, so they still can amplify. You can have non-anonymous amplification, though it's a much weaker attack because if you're getting like a zillion, if like Martin's coming in with a zillion requests, it's pretty obvious.
Ben Kadek, well, I mean, you have to be able to store the address in your session ticket or whatever with your resumption state, and then you can use it as an address validation.
Yeah, people do that as well.
Yeah.
So this is great for the handshake, but there is also the addition of connection IDs to the protocol, which means that you can use the protocol on new paths based on an existing handshake. And we don't have any explicit path validation mechanism in the protocol, which makes it a little interesting.
That I feel comfortable saying is an application issue. Because there's no migration mechanism in the protocol either.
In what way do you mean?
That basically,
I mean, connection IDs give you a lot of that.
It doesn't. No, you have half of it, but it doesn't. But basically, there's no like there's no instructions if you get something from a new IP address to start sending out IP address, and it wouldn't be good to because then you have connection termination attacks. So we assume that's like when we read connection IDs, we're supposed to decide to keep migration out of the protocol.
Right. So do we say that?
No, but we could if you want.
I think we should.
Yeah. I mean, details doesn't even know what IP address is really.
Yeah.
Janayanga, does the spec say that the same connection ID must not be used on multiple paths by the same endpoints?
Not even really.
Okay.
Kind of just make some noise about it.
I mean, given that connection ID is a construct that's in DTLS and not available to the application, it might be something. It might be worth saying something about how some sort of a signal from the application, if the path has changed, might be useful for DTLS, and DTLS can then use that to change the connection ID.
Sure, I can make a note of that. I can do that if someone can make a note.
Thank you.
Thank you. Okay, next slide. This is me. I think this is just like really editorial. The spec doesn't say what to do. So in DTLS 1.2, there was a cookie, and in DTLS 1.3, that got moved into the cookie extension because we had cookies for HRR. So there's no good reason to have a non-empty cookie in the cookie extension. So my proposal is just to forbid doing this and require the server to detect it and choke. So I think this is really just an editorial issue at some point. Okay. 72. Martin asked if we need key separation with TLS versus DTLS. My proposal is no, and the reason is following. The transcript is different, the headers are different, because the handshake headers are different constructed, so there's no chance that you can have it, and the record layers are as well. Thank you. So there's no. So even though you can't get the same key, you can't have a TLS DTLS. You shouldn't be able to have a TLS and DTLS like proxy that would take like the TLS messages and send them the DTLS connection and get the same keys out. And even if you did, the message wouldn't be correctly formed when you used them. So I think this is going to be fine. So I propose nothing. If Kenny or Karthik comes and tells me something different, I will change my opinion. Implementation status, lagging a bit on TLS 1.3, but we now have implementations in NSS, Mint, and Embed. I thought I sent you new slides, which had better interrupt story on them.
You did.
So the interrupt story has improved slightly from this slide, in that we got interrupt between Mint and NSS, I think yesterday. These are somewhat genetically similar implementations, and I did some of the work on Mint, but the final work was done by Chris Wood. I'm not sure what the state of Hannes is, but Hannes and I have been getting together to do some hoping to do some implementation work together and get that working as well. So hopefully have interop there as well. These are both draft 30, I think, but 31 is unchanged. If I recall correctly, they're actually displaying the release version number just for convenience, but otherwise they're the same. That's not. There's a few more tests I want to run, but I think that looks basically okay. Post next steps here. I want to update the issues as discussed above. There's a few more editorial issues, which I just haven't dealt with, but are easy to deal with. I'll generate a new draft, and we'll try doing a little more interrupt testing and send a report to the list. And after that, I think we're ready to go to the ISG.
Yeah, so I mean, that's the question, whether they come back and do another working group last call, and I didn't see anything that actually kind of warrants that. So I think if you guys just continue to interrupt, and if you find anything, great, and if you don't, then we can just push it forward.
Yeah. We're also going to start to deploy this in Firefox. All right, thank you.
Cool. And you gave us a minute and 30 seconds back.
Did anybody else send us updated slides?
Who's next?
Yeah, all right.
Hello, I'm Alessandro. I'm one of the authors of the certificate compression draft. There hasn't been any major update on the draft itself since the last presentation, I think a year ago. except a few small changes. There have been some developments on the implementation and deployment side. Boring SSL integrated some support sometime last year, and Chrome shipped it in July. I don't remember the specific version. Cloudflare also integrated the Boring SSL support and deployed it on, last year in September. There's been also some work from Apple, I think also Boring SSL, and from Facebook. So we were able to collect some data from the Cloudflare point of view. What we see is an average 1.5 kilobyte reduction in the certificates for both ECDSA and RSA. ECDSA went from about 3.5 kilobytes to 2 kilobytes, RSA from about 4.9 kilobytes to 3.5. So one of the main reasons why we did this work was to reduce the potential amplification factor during the quick handshake, which uses TLS 1.3. The quick specification allows the server to send about 3 times the amount of bytes the client sent in its first flight before the address verification. So the client is supposed to send at least 1,200 bytes. So the server can then send back something like 3.6 kilobytes. With certificate compression, we get quite a good headroom with ECDSA, but for RSA, it's not there. We still need more space. I forgot to point out that Cloudflare uses Broadly compression with the default compression level. So tweaking either the compression level or the CA used, we can probably save more bytes. Do you have a question?
Just a quick clarifying question.
Yep.
The numbers you're talking about here, is that for the whole certificate chain you're presenting? So
Yeah, that's the whole certificate chain.
Okay, thank you.
That's it.
Do you know, Asado?
Yep.
This is really interesting. Do you know offhand how much of that value you're getting is because you're co-compressing, like, the issuer and the subject?
Sorry, what?
So, I mean, do you know how much? So, do you know offhand if you just compressed like the EE certificate, how that would compare to compressing the chain? Like if you get a high compression ratio, or is part of the value you're getting, there's duplication between the subject and the issuer?
We don't actually have those numbers, okay. But our chains are, I think, most of them are like 3 certificates for each chain.
Right.
So you divide that by 3, I guess.
Right. I'm just wondering, like, for instance, the name, like the issuer name is duplicated between, the issuer name, the issuer name is like duplicated between the subject of the issuer certificate and so I'm just wondering, are you part of the value you're getting that you're compressing redundancy between inside the chain or not?
No, this is like the full chain, so we don't have the numbers of it.
Okay, no worries.
Yeah. So there's just one remaining open issue, which is the attack Subodh presented sometime last year. The idea is that if the decompression function produces different results based on the timing it receives the data, an attacker might be able to, for example, delay network packets and then cause the receiver of the certificate to basically process a different certificate than what the sender sent. It was pointed out that the same problem basically applies to AES-N1 parsing. It's just that compression is something that we would add on top of what we already have. Next slide. So one potential solution is to just add the decompressed certificate to the handshake transcript as well. Either by adding both the compressed certificate and the decompressed certificate, or just the decompressed certificate. So the question is, do we want to fix it? Do we actually care? From the mailing list discussions and from talking to people in person, it didn't seem like there was a lot of interest in this. But the discussions were like pretty small anyway. So you tell me, I guess. Next slide. So yeah, so besides that issue, I think that we think that the draft is ready. So if we can actually solve the issue I mentioned, we should probably go to last call.
Yeah. So I guess the question is there anybody that like is going to get up and fall on a sword about the open issue and the way to solve it? Because it's been out. I mean, that issue's been posted for 6-8 months,
A year.
maybe a year. So if we want to do it, let's do it. Otherwise, let's push this document out the door. Go ahead, Hannes. Or Victor, do you want to go first?
Sure. So Victor Vasiliev, Google. What I wanted to note is that the issues with potential attack and compression, while the issue itself is very theoretical in nature, fixing it will lead in various ways of fixing it to various forms of headaches, and which are not theoretical, unlike as opposed to the issue, which is theoretical, which is why I would advocate for not fixing it.
On the open issue, I wouldn't want to have the decompressed certificate in the transcript because it makes the implementation much more complicated. Because in a way how most library, including ours, works. So at that time, when you process the packet and create the transcript, we actually don't pass the content, so it would be not good. A separate question: Did you look at the code size of the functionality, and specifically the compression algorithm and the RAM requirements? I would be curious about this in light of many of the discussions we have currently in the IETF about TLS being too heavyweight and so on and so on.
Right. So we do have some numbers on the actual compression. I think it's kind of like we saw some increment in CPU usage. I think it was about 1-2% globally. I don't know if that means anything to you, but. So this was on Cloudflare's Edge network.
Okay. So, but you didn't do anything on a sort of more client-side device?
No.
Okay.
So I don't think Chrome had any data on this, but someone else might correct me.
Ben Kaduk, it's kind of interesting that Hannes was up before me to say that he doesn't want the decompressed certificate in the handshake, because I was sort of considering the case also for IoT, where you might have an extreme compression function, which is like a 1-byte index into a table of certificates. And in that case, it's a lot dicier because you might have some misbinding problems. But I also don't want to suggest that we muck around with all our TLS implementations to have the decompressed certificate in the handshake hash just for the benefit of IoT stuff.
So Martin Thompson, I'm reading this description and listening to what you said about this, and I don't understand how this is possible. Can you give us a little bit of a?
I think the idea. I think the idea is that you have some kind of compression function that is either like specified badly or it has a bug in it. And
so don't do that then.
Yes. So that would be one solution.
So I guess we don't really say what requirements we have on our compression function, that it's got to be stable over time, say, given the same input. You could sort of consider this like index into a lookup table to be a compression function in a strange sort of sense. But I assume we don't actually want people to use that in this case.
We're gonna cut the line here.
So I think that the main point here is that is the part where an attacker can somehow influence the process. I don't know if like whatever index compression function would allow that.
So there's an important point there, and that is that if we're putting the compressed form into the transcript, we need to ensure that the identity is in the transcript in some way or other. Now, it doesn't matter if it's compressed as long as it's in that form. So we talked about this with cached info. You're compressing it, but you're providing a hash that has a sufficient entropy that you're not exposed to the thing that Ben was talking about with the misbinding attacks, because, well, if anyone can manage a misbinding attack on a hash, then you're free to cache that in any time you like. So yes, I think that's what the fix is define the requirements on the compression function in such a way that you can avoid these problems. That leads me to conclude, however, that the dictionaries that I've been advocating for might be a bad idea.
So the thing is, I guess most compressions wouldn't actually compress, for example, signatures or public keys. But I guess like you can describe a compression function however you want. So, yeah.
Yeah, I'm much less concerned about this particular flavor of attack. I think that the relevant concern is it somehow possible to have, I'm not sure, I'm just thinking on my feet, a collision in a compression function where there are two things that compress to the same thing. But that seems like it's going to have other problems, like operationally, aside from like identity misbinding issues. So I think we have to convince ourselves that the compression function is collision free.
So I think the point I said before was that sounds like a bug in the implementation rather than a potential attack that someone might.
Well, if you had a lossy compression function, you wouldn't be collision free, right?
Right.
So it has to be lossless, right?
Sure.
I think that's the relevant requirement. Unless if I'm thinking correctly, that it has to be like that it has to be injective, right? Yeah. I'm not concerned with this defect issue. I think it's like as you say, it had to be a bug in the decompressor. I think it's vastly more likely the bug in the decompressor is like an uninitialized memory, a UAF or something else. I think that seems much more likely than this, and that'd be much more serious. So I think we should proceed with this as it is and just document the requirements that the function be injected.
So in the idea, just put in the security considerations. If you had something that was so badly designed that it did X, you'd have this problem. So don't do that. That's basically what I think we're getting to, right? Okay.
Victor Vasiliev, I wanted to answer the question about the binary size. So the binary size of Brotli is quite substantial because it carries a giant dictionary with it, which is why this is mostly intended for clients and servers which serve web content, because when you serve web content, you want Brotli for other reasons. And this is trivially, both clients and servers can trivially choose to not implement this, and they will work just fine.
Yeah, I mean, the spec also specifies support for Zillig, so if that's better.
Yeah, Daniel Franca, Akamai. It seems to me that the constraint we want to state on the decompression function is more or less already implicit in the word function. If it has more than one possible output for the same input, then it's not a function.
I mean, so I think we got a way forward, right? So if you can write that up, you write that up, put it in the security considerations, and I'll hit a button to make a working group last call happen, and we can note that specifically as something that was new that was added.
Okay.
Thank you very much.
Thank you.
All right, delegated credentials, Nick.
All right, hello. I'm going to talk about a draft that is on draft number 3. It's been adopted as of a very long time. We haven't talked about it for a while, so it's due for an update. So just as a bit of background, if folks remember what this is, it's meant to help protect internet-facing applications from having their long-term TLS keys in memory, allowing them to instead have a shorter-lived key in memory and keep their long-term key somewhere else. There are other proposals to do this via HSM, remote HSM type of applications. There was, I believe, a BOF lurk about this, but the motivation behind this change is to do so is to not introduce the latency that these proposals introduce. So just to kind of spell that out, if you want to have your key in a very secure location in, say, west coast of the United States, and have traffic in Europe, you may have to incur additional latency to do the handshake. So this latency comes here. In delegated credentials, the way it works is that a short-lived key is issued to the web server every X number of hours or every periodically that is signed by the certificate's key. So it comes with some additional parameters. So very specifically, it's the way to think about this is not as a sub-certificate, it's more as a time-bounded key swap. This is how Richard Barnes described it. So on the right here, you can see all the aspects of it. It's not an X509. It doesn't have all the different details of this. It has specifically see where it says protocol version. This has been this is the part that's been changed between version 2 and version 3. Almost everything else is the same. So what signature scheme it can use, how long it's valid relative to the starting time of the certificate, and a key. And that's basically it. So the way that delegated credentials works in TLS is there's a client extension that is an empty extension that advertises support for it, and then the server responds with an extension on the certificate message that contains this delegated credential. And in terms of the handshake changing, the certificate verify, rather than using the public key of the certificate, you use the public key of the delegated credential. And so to validate this on the client, there's a requirement for the certificate to have a specific object ID that enables this feature. But other than that, all certificate constraints still apply. So the subject alternative names, any of the key usages, everything that's on the certificate still applies to the validation of the connection, including revocation, any certificate transparency requirements, they all apply to the certificate that's delegated. The credential structure itself is validated against this public key in the end entity certificate. And then obviously the certificate verifies is checked against the key in the delegation. So this has several benefits. You can put the signing key far away. You can centralize the control of it. You can kind of split your operations for key management into short-lived, fast-rotating keys and a long-lived, more secure key. And this doesn't have the risk of expanding the scope of the certificate, unlike, say, adding additional certificate at the end of the chain and relying on name constraints.
Chris and Osio, so it's an extension to the protocol.
Yep.
So if you have clients that don't support the extension, you still have to use the regular key?
That's right. So it can be used in conjunction with one of these remote key mechanisms.
So you still have to keep the long-term key in memory while you have the short-term key, or because
no, there's several options. There's if you want to keep the long-term key far away, you can continue to do that. If you want to refuse connections from clients that don't support this extension, you can choose to do that as well. And those would be the two ways to not have the long-term key in the local memory.
It's worth noting there are a couple other benefits here, aside from, sorry, I thought I was. It's worth noting there are a couple other benefits here aside from the security benefit Nick's suggesting. I mean, basically the idea is you have these remote data centers, right? And so you can remote key protocol in the way Nick says, you can backhaul the data all the way back to your main data center. But the point is, your remote data centers, you can have a lower security level than your main data center. But the other thing that's worth noting, another benefit is deploying new algorithms. So like ED25519 is like very slowly rolling out in CABF. In fact, not really rolling out in CABF, but this lets you deploy ED25519 today.
Yeah, good point. This does allow different signature algorithms that may not be in X509.
I mean, not just different signature algorithms, also you can deploy like Diffie-Hellman keys into a semi-static, like OPTLS style Diffie-Hellman if you wanted.
That's correct. If there were changes to TLS that were adopted that would allow different types of identity keys, then this would support that.
So Martin Thompson, in the case that you wanted to use a new type of signature algorithm, the client would have to support both the signature algorithm on the end entity cert and the signature algorithm on the delegated credential. And so that's a little limiting, but it's certainly a lot better than it has been.
Rich Sauls, you're not worried about the size of the browser executable, are you?
No, it was just a point. That's one way of thinking of this is an extension of the certification path, but it's not. It's an in-protocol thing, which just means that now that you have to deal with two signatures, you have to deal with potentially two different signature algorithms, and that was sold as a feature, but it also means that you need to have the code for those things. NSS doesn't have ED25519 at the moment, but
Yeah, it's really more a feature from the server side because it means you can have a server that only, so the same ways you can have the server with backhaul, you can have a server that only does one, or you can just, or it's just the algorithm is faster, so you can save server CPU. I mean, generally, like, it's pretty much not possible. It's not going to be possible for like the foreseeable future to have like, even if ED25509 was like rolled out by CABF tomorrow, it would be possible for the foreseeable future a browser client that didn't do P256. I mean, it's not possible a browser client doesn't do RSA.
Right. So on the client side, the validation of the handshake and the validation of the PKI, if they're separate, like they are on a lot of platforms, this allows you to rely on upgrades to the TLS stack without necessarily needing upgrades to the PKI stack. And the certificate, I guess the signature algorithm extension is reused in this case. So this is the same thing that you rely on. So updates in 03, there was some short discussion on the list about protocol version. So this was removed. This is TLS 1.3 only, and there are no non-TLS 1.3 versions. But in any case, it is potentially useful for future versions of TLS 1.3 without changing the structure of the credential. There is now server implementation of 03 in Boring SSL. There is a server deployment here at this website with the proposed OID, which is issued by DigiCert. There's a hiccup in deployment, so we're going to try to fix that by tomorrow. So this is optimistic. In any case, there's ongoing work to support this in NSS and Firefox as well. And so not only have we kind of kickstarted this from the implementation standpoint, we started some initial discussions on the policy list, the Mozilla's policy list, about interactions with the CA Browser Forum, and we don't necessarily see any negative points being raised from that would block the distribution of this protocol. So next steps, the one thing that we wanted to have here is some sort of formal security analysis. So we've grabbed somebody to do that. Essentially, the properties we want to prove that this is equivalent from a security perspective of having an additional certificate in your chain, as well as we want to have this brings stronger binding than you would for a PKI chain. In PKI chains, you can change the intermediate and use the same key, and it's still fine. In this case, delegated credentials are specifically bound back to the credential itself. So the questions here are, pending the formal security analysis, are there any other questions? Does the working group think this is ready for a last call? Should we wait for the analysis, or what are the next steps? And are there any questions?
Yeah, Rich Sauls. Is the intent that the client who supports this, are they expecting if they speak to multiple servers that they all have the same delegated key? Or is it just, it's going to still follow the same PKI rules, and then there's, in essence, an extra key exchange rule to follow?
It's like you're seeing a certificate that swaps out its private key for another short-lived private key. So there's no assumption of keys being pinned or anything like that.
I think we should wait for the analysis. Like, I mean, we can still get test deployments going, but like, I think a good policy for this working group going forward is things on the standards track need some kind of formal analysis. It was like a good idea for 1.3. So,
okay, that was what I was hoping for.
Okay,
that's
great.
it.
Thanks. Next is ESNI. Chris. $520-ish? Yeah.
All right. Hello. We're here to give you an update on encrypted SNI. For those that are unfamiliar, just a quick summary of the problem as it exists today. Assuming you're not using an encrypted DNS or you're using a legacy version of TLS, your network traffic leaks a lot of information to any passive observer via the DNS query itself in the query or answer, or in the TLS SNI, or in the certificate that comes back. But if you lived in a world where you had encrypted DNS via DO or DOT, and you had TLS 1.3 with encrypted SNI, the amount of information that's actually leaked from those particular places in the packets substantially reduces. Still, it's not a perfect solution, but it's certainly a step forward in the right direction. So in the latest update of the draft, several changes went in. Probably the biggest one was the pull request from David Benjamin to improve robustness, basically to add a secure fallback signal or a secure retry signal to get a new ESNI key in the event that the client doesn't have the right version of the ESNI keys anymore, or the server misplaced it or whatever. We also added a rule that prohibits sending a cached info cert. So we specifically because we don't want to leak what certificate the client has previously cached in response to a connection. We added some clarifying words around HR behavior, although there's still a little bit more that needs to be done there. We added also an initial simple, say, design for the multi-CDN problem that is the combined records approach, along with a mandatory extension mechanism in a way to specify whether or not a particular extension in the ESNI record is mandatory. By mandatory, I mean not mandatory to implement, but clients which get a mandatory extension and they don't understand it, they must ignore the ESNI record that comes back. So I'll describe this solution a little bit more in a couple of slides. And in kind of landing this initial PR, we also dropped the ESNI prefix for the special DNS query and moved from a text record to a new R type per advice that we got back from various stakeholders. So there are also some pending changes that are probably ready to land, particularly the Greece one from David Benjamin as well. It just needs, is it up to date? It is? Okay, so we should merge that relatively shortly. There's also a PR to swap the version and checksum fields in the ESNI keys record. If you believe that the checksum adds value for version 1, it likely adds value for any kind of version of ESNI. So by swapping them, you're effectively making the checksum an invariant, which seems okay if you buy that particular argument. So assuming there's no pushback, we'll likely merge that soon. And then there's another work in progress pull request for a more generic solution to the multi-CDN problem, which is something I'm going to talk about and hopefully we'll have a longer discussion about in just a little bit. So to kind of go into detail about the multi-CDN problem, there's these DNS load balancers out there that could be doing strange things such as, redirecting or giving you different answers to different A or quad A answers to different CDN providers based on any kind of deterministic random strategy for load balancing amongst these providers. And I guess that happens quite often, as Mike will likely point out. And they can either do this by just giving you an A or a quad A record that points to this particular provider, or giving you a CNAME that points to a different provider. So say, for example, if in what's listed, if you query for www.example.com, and you might get back a CNAME to CDN1 versus CDN2, depending on what the load balancing strategy is. So the failure case that occurs is because you're doing your A and quad A queries and your ESNI queries independently from one another, not atomically bound. You can wind up in a situation in which the addresses that you get back from your A or quad A queries are effectively provided by one CDN or one provider, and the ESNI records, and it says text, it should be not text. The ESNI records that you get back are provided by another CDN provider, and that doesn't work because CDN2 in this case doesn't, or CDN1 doesn't have the ESNI keys for CDN2 and vice versa. And the robustness technique that we added does not allow you to fall back from this particular scenario. So either you have to hard fail in this case, or you fall back to plain text SNI, both of which are not great. And ideally, we'd like to avoid hard failure in order to make this work. So the simple PR that landed effectively works as follows. Combine the ESNI keys and the A and quad A records into a single simple record by adding the addresses to an ESNI extension that marked as mandatory. And then when you query for the ESNI records and you get back one of these that has a set of addresses that you can connect to, you simply go ahead and use them. You ignore everything you get back from the A and quad A records, because one could argue that this is potentially how DNS could have and should have worked in the first place, just being able to add more information to a particular record. So this is potentially controversial in the event that, or if you view it as deprecating A and quad A records, but it seems fine, particularly if you're a client and you're talking to a provider that's able to vend these particular records and make sure that they're always in sync. It seems okay. There's a couple of pros and cons here. The pro is that it does not matter how often the mismatch occurs between your addresses and your ESNI records, because you're simply not using the A and quad A records at all. The mismatch rate is completely irrelevant. The con, of course, then is it requires a provider that's able to actually make these records and make sure that the contents of the ESNI record match those that match the addresses that for the host that they happen to service. So some providers out there can do it, some cannot. So that's the trade-off. There is the general PR or the generalized PR that's out there right now. This is what's written is not effectively what's in the text. What's in the text is arguably a lot more complex. But effectively what we're trying to do is allow for the addresses that are contained in the ESNI records to filter or to act as a filter for or like a validity check for the addresses you get back in the A and quad A records. So the algorithm basically works as follows. You would query for your A and quad A records, query for your ESNI record, and assuming you get everything back, and you get back an ESNI record that has one of these address pointer structures which contains a net mask inside of it, or one or more net masks. You use them to match against the addresses that you get back from your A and quad A records. If they match, go ahead and use those addresses and connect just fine. If your A or quad A answers happen to resolve in a CNAME chain of some sorts, and the CNAME or the canonical name, or not quite sure what to call it, the name inside the ESNI address pointer record happens to match the CNAME that you got back from the A or quad A record, use the address. Otherwise, you have to take the name that's in the ESNI record and resolve that to an address and then connect to that one. Because presumably that particular record has been constructed in such a way that the name will ultimately resolve or must resolve to a host that is serviced by the same CDN provider. Otherwise, you've royally screwed up and things will go badly. Of course, now the efficacy of this particular approach depends on how often the mismatch occurs. So if you have a scenario in which mismatch occurs, say 50% of the time, that means you will be doing a second sequential DNS query to resolve the name that's inside the ESNI record to an address 50% of the time if you don't want to run into hard failure. It's also problematic because depending on how you're doing your happy eyeballs, like querying for your A and your quad A and your ESNI records, you might introduce a delay of some sorts in order to get your initial ESNI response back. So the time it actually takes to go from nothing to ESNI keys and address, some addressing information could potentially be quite long. So not only are you paying the hit, but the time it takes to actually start connecting could substantially increase, which is not ideal. So the proposal we have for the group is as follows. Because we have a working solution in the document right now that is it makes the mismatch rate irrelevant, provided that you can actually vend these particular simpler ESNI records that have the full addresses in them. We propose moving forward with that, taking the generalized version that is in 137, making that an extension, potentially in a separate draft, and working on that, and I guess either bring it back to the working group or something. So I'm hopeful that people who are opinionated about this particular topic will come to the mic now and tell me whether or not they're okay with this, or if not, because the multi-CDN issue was the big thing we needed to address in order to move forward with ESNI. So I would really like to see something happen here such that we can get ourselves unblocked and move forward. So, Stephen.
Stephen Farrell. So as a kind of a slightly nitty comment, but it impacts on the moving forward part. I think expressing these as extensions is a bad idea, and having any extensions in this is not a great plan. Is my personal opinion.
Do you mean any extensions in ESNI or?
Yeah.
Okay.
Which, if everybody bought into that, which I don't think they do, that would rule out this path, right? On what 03 has, I just kind of worry that it'll cause another shitfest with a bunch of people who have dependencies on how A and Quad A records are managed and therefore wouldn't be able to use ESNI.
But because we're deferring this to an extension, assuming you buy the extension thing, and because we're deferring it to an extension, it does not prohibit them from doing that later in an extension.
Right.
It simply enables the people who want to do ESNI in the way that's currently specified to do it.
Right. If you assume that everybody then implements both.
Not everyone might implement both. So if you're a client, and what is the incentive for a client to do the more general one if you're paying a potential?
But it's the server side who has the dependency on the A and Quad A management.
Right. But if the clients are paying a substantial performance at a large fraction of time for one of the designs versus the other, there's not much incentive for them to do the other one, regardless of how hard or easy it is for the server to actually do it.
Right. So my point is that with this plan as making an extension draft, if there's some servers in the world who, for whatever reason, manage their A and Quad A so that they can't use what's in 0.3,
yep.
Then and if clients only implement what's in 0.3, they're not able to use ESNI.
Would it be useful to hear from a client?
Yeah. So
okay. You want to wait? Sure.
My response to that would be, as a client, so I'm now speaking as a client, as Apple, we would not, it's very unlikely that we would implement a solution that had a performance regression in this, that PR137 potentially provides or gives us. So regardless of whether or not it's in the draft, or in this draft, or in a separate draft, it doesn't change the fact whether or not we'll implement it. We're looking for something to implement.
Yeah, I haven't talked to anybody on either side that's interested in the potential terminal regression case of 137 if it were a common case in pursuing that, like as an acceptable cost if this was happening all the time. There are different opinions on how often this happens. I think that's kind of the territory we're in.
So Mike will hopefully clarify that in the follow-up slides, but yes, go on.
Yeah, and I've heard whispers that's kind of scary data. I might ask that I be given some time rather before moving on to see if I could replicate that data or have a different data point, because if it's really scary, and this is like talking about Mike's presentation before he's made it, which is completely unfair. But that's kind of what the question is asking as well. It's not intuitive to me, so I'd like to understand it more deeply. The current solution in the draft actually does impose a performance penalty as well, right? Because you're essentially racing an A lookup with the ESNI lookup, right? And you're giving you're tolerating a certain amount of time, right? Isn't that the connection delay part?
Yes, but you're doing that regardless.
No, I'm saying, so this whole solution it brings on a little bit of incremental overhead, right? Because you're waiting to see if you get an ESNI record.
Yes, of
after
course.
You've gotten an A record, right? So that's part of this. But yeah, to me, the most important thing is, and I'm wandering around the topic, is that we sort of soft shoed like deprecating the A and Quad A. And as a guy who's kind of done that at an HTTP level in a couple different ways already, this will surprise a lot of people. And so to the extent that we can avoid that, like especially at the TLS layer, which I think will be even less intuitive than HTTP directions, which is where I've, earned my spurs on this particular topic. I think we really do want to avoid that because of, if nothing else, all the diagnostic machinery. You'll see requests landing in one place and you'll see people firing up ping and they'll be like, huh? Right? It's going to be hard.
So I can't speak to the difficulty that operators will incur there. I'm hopeful that operators that can do 136, PR136, that is a simpler approach, will, comment on whether or not this is actually a problem for them.
So Patrick, this isn't a change to the TLS layer. This is the application doing a lookup and just telling the TLS layer where to go. I mean, quite seriously, that's how it's implemented, like this in Firefox. So I guess I'd like to try to reframe this discussion, perhaps. The situation we have at hand is that we have some evidence and some worked experience that multi-CDNs, we have a real problem, and that ESNI is not deployable in the current state because it causes a hard fail. We have a number of non-ideal approaches for like dealing with this. This approach is something that we know will work in the sense that it is safe to deploy, and that the client and that the clients will not inadvertently connect to the wrong server and hard fail. And then we know that some servers can deploy and the clients can work, and it has no performance regression worse than the ESNI performance regression itself. Now, it may be the case that there's some mechanism that will be easier for some people to deploy on the server side and will not induce a major performance regression. And I would welcome that solution. And if that solution is available today, then I would refer that solution to what we have up here, even if it's somewhat more complicated for the client to deploy. However, my impression is that it's not the situation, and that available solutions like either have known performance regressions or seem likely to have performance regressions. And I can tell you that as a client, we have no interest in having something which requires like a second DNS resolution in serial before we're going to do a connection. That's like that's a non-starter for us. Yeah, for any substantial fraction of requests, or that happens like reliably for any server. If it was like sub 1% of requests, and it was like some across servers, like including like no server was always taking regression, like maybe we wouldn't talk about that. But like if it's going to be like a major regression all the time, we're just not interested. So that's like the requirement for solution. As far as like the design of the system, I think I was supposed to propose this extension approach. I think the advantage of that is it lets us get some deployment experience with this, with something we know will work for the people who can play well. And then if something awesome comes along that makes this work better, that has the properties we're interested in, we're more than interested in like taking that as well. But this lets us have a smooth upgrade path for those without having like basically the n squared like number of records with all the different possibilities at the same time.
Hey, so we got about 8 minutes left on this topic, so we're going to keep it short. And Nick, you're the last person in this queue.
I forgot to mention one more thing that also Chris didn't mention. The nice property of this extension is that that because we have the bit indicating it's mandatory, that it's quite straightforward for you to advertise ESNI keys with the like some sort of PR13070 thing, and then conformant clients will just reject it if they don't know about it. So it will like upgrade quite smoothly.
Yeah, thank you. Eric.
Eric Nygren. I think on that topic of the what happens when it's mandatory, I think some of that will be a function of how comfortable are we then if adding that extension is an extension like 137 is mandatory. If that means that clients using that then that haven't implemented 137 basically can't use ESNI anymore. Yeah, when I guess when that's being the Echo said that was the intended behavior.
Yes.
And I think that where that starts becoming important is that, like with 136, I think the biggest challenge is going to be cases where the sheer number of A and Quad A records are more that might get used in any one point in time is more than necessarily fit in. I think to Patrick's comment, I think there is a bit of I also do have some anxiety of what are going to be the operational issues we're going to run into of having the A and Quad A records that people use be something that comes from another record that's not A or Quad A. That's something that does have a big enough operational change and breaks a lot of assumptions that could have interesting side effects. But I think until we try to deploy that, we don't know what the side effects of doing that are yet.
So to clarify, are you concerned about the operational risks of a provider who is able to produce those records debugging their systems, or some other operational problem that's outside of that?
The operational stuff of all the complexities of how the internet works between that. Like the example would be like a known case would be DNS 6.4. DNS 6.4 relies on being able to do those rewrites. We can specify that one in the draft and cover that case if clients implement that properly. But it's very likely there are other things we haven't thought of which work by accident and or in undocumented manners that we'll start tripping over as we start trying to roll this out.
Sure. Yeah. Thank you.
David Benjamin. Mostly, I just want to echo as a client, the performance concern, possible performance regressions for ESNI are a significant concern for whether we can deploy it. And so it's already kind of scary that we have to erase 2 of them, and maybe ESNI records are really slow and would have to measure that. If we have to then additionally do this extra round trip, we would want to at least try the first one. Also, sort of fundamentally, the problem with this multi-CDN thing is that you are not managing to correlate 2 things from CDN A and 2 things from CDN B. And it's sort of unfortunate that DNS didn't let us do that, but like that is the thing we want, and 136 sticks them together. And like however you spell that is sort of, we can fiddle with that, but it's sort of more in the right direction, I think.
Yep, agreed.
Wes Herdeker, ISI. So I need to go read the document in greater detail, and I'm glad that I was in the room so that I could see this issue popping up. So I'll speak at a sort of a higher level, which is that I think, this is especially to the chairs, if this is going to go forward, we need significantly more review from expertise that is not in this room. There's some rather large, interesting ramifications of doing this type of stuff where we have, to some extent, you're fracturing the namespace, right? So the DNS is considered this global naming system, and there's already some fracturing because of things like SNI and things like that, where X509 and PKIX certificates tend to have their belief of what a proper name is, and the DNS has their belief of a proper name, and now we're splitting the address space too. And so these danger bells are ringing off in my head, but until I actually go dive deep, I can't be for or against it. But I do think, especially to the chairs, we need to go ping a wider set of people to make sure that there's not other issues here that are not thought about.
I will note that we learned a lesson from one draft that was involved in DNS recently as well. And so obviously we will do that. Luckily, a lot of these people that are proposing this have DNS experts in shop. And my assumption is that they're also consulting with them as well. But obviously we'll have to make sure that we don't just spring this on everybody. We're also not hiding it, right? So,
Eric Klein, I actually would like to second Eric Nygren's DNS 6.4 comment. That will be problematic. But I had a question, so please pardon my ignorance. What are the implications for an authoritative server for a CDN that doesn't use CNAME chasing and does do like geolocation? So if I have 1,000 IPs I could return to you, I'm going to return 3 that I think are in your area. Do I generate 1 ESNI keys record with those 3 addresses in it? Or do I have 1 ESNI keys record per address and give you those 3?
I do not know. I would defer to the server operators that are going to be vending these particular records. Speaking as a client, I don't really care. I recognize that's not like a great answer to your particular question. I don't know.
I'm Nick Sullivan, Cloudflare. So to speak from the server operator's point of view, I spoke with the folks in our team who do this, and the way that we construct ESNI keys as well as A and quad A is from the same database. So we see no problem with 136 and going forward with it. If a query comes in for any one of those 3 types, we look it up from the same database and construct the correct record. And that seems to be pretty straightforward. And so with respect to this, we see no operational issues on the server side.
So perhaps we could, send a message to the DNS ops mailing list or something, indicating that this is potentially what we're planning to do. This is what's currently in the draft, and seek additional feedback.
Whoever's taking minutes, please note that.
Yeah, it'd be good to get some more feedback there. Certainly, again, I'm not trying to dismiss or belittle anyone's particular comments, but this is certainly a difficult problem to deal with, and we're just trying to find the best way to move forward. So there are a lot of other open issues right now, some of them major-ish, some of them sort of minor. The list is here. I will, I guess, call out at least 2 of them in particular. The first is that there's the question as to whether or not we should remove the split mode from the draft. Currently, ESNI works in a shared mode architecture in which the TLS terminating server also is the thing that serves up the content. In the split mode, their TLS terminating server, or the server that actually decrypts the SNI and forwards the connection on to another server that vends up the application data. Potentially there's valid use case to that particular architecture. It does increase the complexity in actually getting the information from the fronting server to the backend server is sort of, it's not well specified, or it's a little bit odd currently in the draft because we don't really have a better way. So if we were to remove that, it would reduce a lot of the complexity. Ecker?
The complexity of what? I mean, it's complex to have the split mode
but that complexity does not project itself into the other protocol otherwise, does it?
Complexity in terms, right? So sorry, complexity in terms of the number of words or the amount of words in the draft. It also allows us to do potentially other things like encrypt more than just the SNI in the client hello. I know there have been people who have desired to potentially encrypt the ALPN values and potentially other extensions as well. So,
sure, yeah. I'm actually hoping DKG's in the room.
He is. He's back there.
I mean, so you're going to want to stand up probably. Oh, well, no, I think we're back open because we're discussing the issues.
Well,
then should I be sitting down? I can. Oh, okay.
I think since we have a bunch of other presentations to go through, I think in terms of managing time, we should delegate. And so take this to the list, guys. There's lots of stuff to talk about. So
yeah, please have a look at the issues on GitHub and comment.
So can I ask one question?
Yeah.
Sure. So I just had a look at 134 there, and that reflects a discussion in GitHub that I don't think matches, which says it was a comment from me, which I don't think matches my comment. So I think we need to manage the GitHub discussion and list discussion maybe a little better on some of these.
Okay. Point taken.
All right.
Yes.
That's
questions,
it.
Lots. Great. Thank you. Thank you for being positive.
All right, so a lot of the discussion around those two proposals for ESNI depends on whether you're actually going to see divergence between an ESNI record type and the A or the quad A results. I was fortunately able to tap into somebody else's research database with lots of DNS resolutions to try and find an answer to that. The problem is you can't actually test something that hasn't been deployed. So I can't directly measure what would happen with ESNI. So instead, we actually have a pretty decent proxy question. We're already doing two resolutions for the same host name in A and quad A. So I'm using the database to try and figure out if A and quad A diverge from each other, and if they do, it's likely that ESNI will diverge from one or both of them as well. So I can't go into a lot of detail about what the database about how it's constructed, but we have lots of host names, lots of resolvers, and every run it takes a random selection from those resolvers, does lots of resolutions. I'm sampling 1 week of data, which gives us about 235 million A and quad A resolution pairs. Of course, we throw most of it away. Because if what we're looking for are potentially divergent cases, we're boiling that down to what CDN were we pointed to. So if we couldn't figure out what CDN it was, doesn't help us. Also, there are host names that use one CDN. And if you always return the same CDN, it's not possible for you to diverge, so you're not helpful in answering this question. And DNS resolutions aren't always successful. Not everybody supports IPv6. So sometimes we didn't get an A and a quad A result from the same resolution attempt for the same server. So at the end of it, those 243 million resolutions left us with about 224,000 pairs of resolutions that actually meet the criteria we care about. So drilling into that little slice of data, we see about 23% divergence, which is a lot higher than I was hoping to find. I was a little surprised by that. I tried to spin it in a couple different ways to see if there was something that tied it all together. If you look at it on a per host name basis, there's like 40% of host names that never diverge, and the other 60 do some portion of the time. If you spin it by resolver, there's about a third of resolvers that give you consistent results, but not most of them.
Hi, this is DKG. Sorry, Mike, I'm just not following. Can you just define what you mean by diverge for us, please?
Diverge means when we figure out what CDN the A record is pointing to and what CDN the quad A record is pointing to, they're different CDNs.
Okay, so you've got this set of 234,000. And my understanding was that set was entirely divergent.
So what happens is So no, that's the slice of things that could potentially diverge. So we know when we were able to identify a CDN for the quad A and a CDN for the A, and we got a result for both of them. Is your question about?
I'm not understanding what the pool is that you're working from here.
Okay.
Because if you're looking for things that resolve to both A and quad A and to multiple CDNs. So isn't that by definition divergence? What am I missing? Sorry.
The ones that I throw away are the ones where every resolution attempt at every resolver for the entire run of the sequence gave me the same CDN. So those I can ignore because I'm guessing they always give the same result. But then what I'm drilling into is for a particular pair of resolutions at the same time at the same resolver, I got different results. Does that help?
It still sounds to me like you're saying every pair that you're looking at in this set here is divergent. So I don't understand why it's 23%.
So
I'm sorry, maybe I'm the only person who's not understanding it, but
maybe I can ask a clarifying question here that might help.
Okay.
If I understand correctly, what you're saying is that the host names don't resolve to the same CDN at different points in time, with potentially different resolvers. And when you're looking at ones that are returning both A and quad A results, when you're looking for divergence, you're looking for them to be at roughly the same time and from the same resolver.
Right. Yeah, so the client that's running the test fires an A and a quad A request off to the same resolver at the same time. The ones that I'm discarding, every attempt over the course of the week from any resolver, from any client, always give us the same CDN, so I don't expect to ever be able to observe divergence there because it always goes the same place.
You're the AD, you ought to go.
Yeah, I mean, this sort of is related to the point I wanted to make, which is that we need to be clear about what these data are representative for. And you sort of described it in that our sample space is already kind of constrained. And, yes, this is a high percentage number, but we may have been throwing out some other cases that, if we don't know which CDN a thing corresponds to, or we don't know that it is a CDN at all, and by throwing those data away, we're sort of increasing the percentage number that we come out with.
And I kind of compare that on my last slide.
Yeah, and the idea being that, so we've got this set of stuff which is is data points that are across space and time, and you've used that data set to figure out, or to try to figure out when there are multiple CDNs, and that's necessarily lossy, and we just sort of have to assume or make inferences about how reliably we can do that. And it's only within that space of data that we're actually looking at these percentage numbers.
Correct.
And I think, as John was saying, when we're actually trying to get something that diverges, that's only if it's diverging at a single point in space and time, whereas we're using this broad set in space and time, broad in space and broad in time, to determine if there are different CDNs involved.
Correct. I think probably the longer a time period I look at, the more representative this would be. When I tried to do a month, it told me I was out of memory, so I scaled it down to a week.
And then it's not just limited to folks with multiple CDNs, it's specifically then constrained because we need an artificial sort of second record type in the test to people that are doing both A and quad A, which I think the first part of that multi-CDN is actually the people we're looking for the problem, but the second constraint is actually kind of artificial to what the working group is considering. So I'm actually curious how big of a filter that last step is on the multi-CDN data set.
Yeah, definitely. That's sort of one of the places where we can't really be sure how much we're distorting the data by filtering it this way.
Correct.
So, so I understand the A and the quad A were sent off, more or less in parallel. There are a lot of resolvers in the data. I'm trying to understand what these resolvers are. Are they the authoritatives or these different recursors?
No, they are open resolvers at different points on the internet. We have a database that we send off requests to.
And how many of those? I mean, you can move ahead to the other slide. I think there were a lot of them, right?
Yes. So there are about 4,500 total that we use. For any given resolution attempt, we send it to a subset of 500 selected from those 4,500.
So those are on your network. They're not open resolvers. They're Akamai open resolvers. Open. 500 of them. That's awesome.
Okay, so one of the suggestions has been that this shouldn't happen that often if it's in parallel because it's not really in parallel. One of them gets there first, and that a CNAME ought to be cached, or there ought to be some back-end connection collapsing happening to make that CNAME get cached, which would then prevent this from diverging. And you're saying that's not happening, or it appears that's not happening.
That was my supposition as well. I thought that this should be fairly rare because either the CNAME's already cached or you collapse the resolutions. And so you would maybe potentially see this when they happen to straddle the expiration of your cached CNAME, or maybe it was cold and it sent both lookups backward. Yeah. I have heard that there are some pathological stub resolvers that then round robin amongst multiple upstream resolvers, which almost guarantees divergence.
Well, are you controlling the stubs? So no. I guess we just talked about what the recursive was. What is the stub in this test?
So I think Eric, who is behind you, is the one who told me about that. So I may let him go into more detail.
Just going to make sure we cut the line too. Got about a minute left.
The example, and one example case is that the recursive resolver service interface you might talk to may actually be load balancing across a pool of recursive resolvers that each have independent caches. And because it's connectionless in UDP, there's no necessary reason that you to necessarily do determinism in terms of which backend server a given request goes to. So if you're just doing pure round robin that's stateless across all of them, 2 requests may go to 2 different ones back to back. Those make issue out queries. If those and then there's nothing to cache.
Do we think that's the right model for client-facing traffic?
Nick Sullivan Club. I'll just say that that's what Eric's describing is common, very common.
Yeah. Whether it's the right model or not, it happens.
Oh yeah, but we're trying to get a number, right? So the question is, for the model, is it the right thing?
So I get thanks for doing this, Mike. This is like great. Like everyone else is too lazy, so it's really awesome you did it. I mean, I guess what I would say is like this is scary.
Yes.
And so I think I definitely love to see like more people dig in. And I'd love for you to be wrong, right? If you're like wrong and this lane was like 0.001, that'd be like great. So like Patrick, like definitely like if you want to run some data here, like that'd be sweet. But I think like you have to be pretty wrong for like the numbers to be acceptable. Yeah. So I don't know. Thanks, and like people who are like sort of beating on this, like like go to them like afterwards and see if you can like come up with a study that makes you happier.
Mm-hmm. So just a clarifying question. So the ASNI keys is supposed to be looked up over TLS, right? Would that make a difference if we're using TCP and not UDP?
It might very well. I don't have a way to test that.
John Iyengar, I think the data is obviously great, and I agree with that, except I'll note that A and quad A might be qualitatively different than other things, but I don't know exactly how to think about that any further or how to turn that into an experiment. But that's a caveat we should keep in mind.
I mean, the only thing I can think of is if we could identify some other type of DNS record that is commonly present, MX, text, whatever.
So do you have, I'm just thinking how one could replicate this experiment now with like maybe the question Stephen asked about Go. Because you're right, we would do this over Go. Perhaps one thing we could do that wouldn't be ideal, but would be some. I mean, let me ask you a question: How do you distinguish whether things are on CDN? Do you have some big ass database?
Yeah. So basically, what happens is if there's a CNAME chain, there are fairly predictable regexes that you can run against hosts in the CNAME to say, oh, this has AKAM.ai. That's Akamai.
Yeah. So we don't get the CNAMEs, unfortunately.
If you get a straight IP result, then you look up the pointer record, and those usually have the same hostname patterns.
Right. Okay. So, I mean, it's one thing. Well, there are 2 ways to look at this. One way to look at this is what's the space, like how often does this happen in general? Mm-hmm. Another way to look at it is how often does it happen for people who like are potentially exposed, right? So
that would be my last slide.
Yeah. Well, awesome. So I guess one thing we could do that I think like Firefox could do is if you want to give us a list of some people who are exposed, we can go and we can ask how often did that happen for them, because we can just do a forced resolution and then compare the A and the quad A and compare those numbers, and then we'll at least get a cross. I mean, that won't tell us how often it happens overall, but if we cross correlate with your numbers and I feel like if it happens 50% of the time for people exposed, that's pretty bad.
Okay, so I hate to do this, but I think we're gonna have to cut this presentation short because we have 4 more presentations, so we should definitely take this.
Can I go to my last slide?
You can go to the last slide.
Okay, so we were talking about how does this affect from the browser perspective versus the server operator perspective. From the browser side, multi-CDN hosts are about 1% of all the hosts that we resolved, and it happens about 20% of the time for them. So from the browser standpoint, this is about 0.2%. If you are a multi-CDN site, it happens about 20% of the time for you, which kind of stings for your site's performance.
Interesting. On that note, mic drop. Literally, mic drop the mic. It's interesting. Okay, TLS.
Okay, I know we're short on time, and this is a lot of content, so I'll try to get through it. Opaque. This is a presentation about a password-based authentication system for TLS. Opaque, we've had these before. SRP is one of the first, which is an augmented password authenticated key exchange. It's widely implemented using a bunch of protocols, but not necessarily on the web. Dragonfly is another one that was recently brought through. It's been published as an RFC, as an independent submission, including integration into TLS 1.2 and 1.3. And so there are some, so if we look specifically at SRP, there's a couple issues with that. One is the salt is sent in the clear, which is actually a problem with almost all of the previous PICs. And so this leads to potential pre-computation attacks. If you get the server's database of passwords, you can have pre-computed rainbow tables to check password databases rather than having to do a brute force. The security analysis of SRP is unsatisfying. I know there's several different iterations and lots of implementation problems. Finite fields, no elliptic curves. It's kind of an awkward fit as described for TLS 1.3, which is kind of more cosmetic than anything. But when it comes to post-handshake messages, this requires a renegotiation. Okay, so that's just kind of a background on SRP and some of the original PICs. And Opaque was presented last year, and this is a new paper that has it's a methodology for describing how to build a secure asymmetric PIC in conjunction with a authenticated key exchange like we have in TLS 1.3. So the way that this is presented by Krawczyk and others at Real World Crypto, there's a paper published. There's also a proposal that's been through several iterations at CFRG. So the way it works is you take an authenticated key exchange like TLS 1.3 and combine it with a primitive called an OPRF, which is an oblivious pseudo-random function. I'll give some intuition as to how that works. And if you combine them together in the right way, Opaque describes how you can get a secure APIC out of that. As a PIC description primitive, it has some really nice properties such as security proof. It is the first one that's provably secure against pre-computation attacks of all the PICs that are published, as well as it has a very efficient implementation based on elliptic curves. So as I mentioned, Opaque, this is a draft that we wrote for TLS working group, but it depends on a bunch of other primitives that are currently going through the CFRG, specifically the Opaque overview, the OPRF, which is currently an individual draft, as well as hashed curve, which is a dependency of that OPRF draft, which is currently an IETF document for CFRG. Okay. Fundamental components, OPRF. This OPRF protocol it allows two parties to negotiate a value based on something that the client provides, something that the server provides. The output of this protocol is not known by the server. So you can, I'll sort of explain it a little bit later, but essentially you have a server with a private key and a client with a value like a password, and you get a result that's based on both of those. That involves a one round trip flow. So in the construction for opaque, this OPRF, the output of the OPRF is used to encrypt an envelope which contains a set of public keys, or that contains opaque keys, which is, if you think in TLS, when you're talking about key negotiation, you have your signature keys and you have your key agreement keys. This is another pair of keys. It could be either signature keys or key agreement keys. These are keys that are tied specifically to the user's account on that specific server. So in terms of what's inside this envelope, you have the client's TLS 1.3 compatible private key, as well as the server's public key. So I'll go a little bit into the math. I know this is we're tight for time, but to get a bit of fundamentals as to what this relies on, it's the same sort of thing that TLS 1.3 relies on. So you have a prime order group. So for example, the group of points on an elliptic curve, such as P256. These group elements are denoted by capital P or capital Q. You have scalar multiplication, which is adding a point to itself n times. Scalars will be lowercase letters. And then there's an additional element here called #2 group element. This is something that almost all PAKEs have taken into account, and it's how you get from a password into the group. This is, as I mentioned, currently being gone over at the CFRG. So it takes a scalar and outputs a red group element that is uniformly random. The OPRF flow kind of looks like this. The client takes a password, blinds it, sends it to the server. The server applies its private key operation, and you get a blinded OPRF out, and then you can unblind that OPRF. So this password and the unblinded OPRF are tied together by the server's private key, and same with the blinded password and the blinded OPRF out. In terms of the math of it, you can think of a blinding value as just a random value. So you take your password, you hash it into a curve element multiplied by the blinding value. That's your OPRF1 value. Send it to the server. The server multiplies by its secret scalar, sends it back. Then you divide out the blinding value, and then you're left with the server's private scalar times the point that represents your password. And this OPRF flow is the fundamental basis for opaque. And so the final output there is what's used to encrypt the envelope that contains the extra keys. Okay, am I going forward or backwards? Here we go. Okay, so the user creates the envelope during password registration. It runs the OPRF and puts its own private key and the server's public key into the envelope, sends it back to the server, and the server saves it with the identity of the client. And for this to work as part of a handshake, the user provides knowledge of the password by being able to open the envelope and use the keys that are the private key inside, and the server knows the associated public key. So these private keys are used to authenticate the handshake, and there's two main proposals in this document of how this can be done. The opaque private keys can be used in place of the PKI keys. So if you think of the certificate verify, rather than using a certificate and private key there, you take the opaque private key and use it in the certificate verify in client authentication. Or the other way is to take those keys and mix them with the key agreement keys in a kind of 4-key based key agreement and use that as part of the key schedule. So this is sometimes called triple DH, and there's a more efficient version called HMQV, which is, I believe, has some IPR, but Hugo said it was fine. I think we're probably safe from it for now. But in any case, the details are in the graph. So how does it work in place of PKI keys? This is the instantiation called opaque sign. So your opaque keys, the ones that are in the envelope, are signature keys. The client sends its identity in an extension, as well as the first OPRF, and the server sends back a certificate message that has its piece of the OPRF as well as a certificate request for that identity. And the certificate verifies the server's opaque key that's associated with the account, and the client's then completes the client auth flow with its certificate verify is the client's opaque key. So in this instantiation, there's no PKI at all. Anything that you would do in terms of certificates in TLS 1.3 are replaced with these opaque keys, which is kind of nice. The other way is to take the result of these keys and throw them into the key schedule. So in this case, the opaque keys are TLS 1.3 key shares. So the client takes the identity, OPRF key, and then the OPRF key is the key share that is used for the key negotiation has to match the type of key that was in the envelope. So you have essentially 2 client key shares and 2 server key shares. The server sends back an encrypted extensions with the OPRF2 keys. Encrypted extensions is derived as the normal key exchange flow works. So just with doing the regular Diffie-Hellman. And so the master secret is actually derived. There's a specific place where you do an HKDF extract of 0 to get the master secret and the handshake secret from above it. And what you do here is you replace 0 with this value k, which is essentially a 3-way Diffie-Hellman between the ephemeral keys and the opaque keys. Or it's MQV is the same sort of thing, it's just more efficient to do so. And the interesting thing about this instantiation is that you can also have a certificate and do regular PKI auth, both client or server. And the reason why this is relevant is there's certain applications where you could think that you would do opaque to do individual auth, but you'd also have some sort of higher level auth, like, oh, all of these devices belong to the same or were manufactured by the same manufacturer or something like this. You could do some PKI system and augment it with PAKE. Okay, so these are the 2 in-handshake modes, and we talk about using PAKEs for in-handshake modes because you're activating devices or things like this. But when you think about potential uses on, say, the web, you're not going to want to do have the user experience of typing in a password before any of the content loads. So having a post-handshake authentication option here is pretty interesting. So because opaque sign is really just replacing the PKI auth, it actually maps really nicely onto exported authenticators. So the client can create an exported authenticator request with its identity, its OPRF key. The server can send back an exported authenticator with its OPRF signature key, and then also initiate a second exported authenticator flow where the server asks the client to authenticate itself. And so you get 1 round trip flow. And this uses the exact same structure that opaque sign does. Okay, so properties here, opaque sign is there's no username privacy, so the identity itself is sent in the first request. This is a problem with both of these in-handshake forms. There could be some ESNI type mechanism that could be used to protect this. Opaque sign does not have PKI auth in the handshake. And opaque sign in exported authenticators, because it happens after the handshake, it requires PKI auth, but it does provide username privacy, and it can fit potentially nicely into things like HTTP2. You could think of, rather than having an additional certificate that uses exported authenticators, you could have a opaque flow that is part of HTTP2 frames going forward. So as a recap, this draft proposes a new password-based authentication mechanism for TLS 1.3. Opaque is the first secure APAC protocol, provably secure against pre-computation attacks. There's multiple constructions, and this is I guess the main question for the group is this interesting for the working group to pursue as an alternative for SRP, or for having some sort of PAKE that works in TLS 1.3. That's the end of the slides.
And again, we'll have to keep it quick.
Yeah. Ben Kaduk. So, I mean, I agree that SRP is kind of lousy, and it'd be nice to have a better option. I don't know what we can really do here other than say that people should read the draft and think about it more. Like,
That's exactly where we're going to go with PAICs. We have a long history of needing to make sure that they've been blessed / looked at by the CFRG before we give them a go point in the whole 9 yards. So, yeah.
Yeah, I think I was going to say much what you just said. Namely, this seems interesting. Obviously, Hugo Karchak has a really good reputation, and this has been well reviewed from what I understand. Kenny tells me it's good. I'd love, I think we shouldn't take it without CFRG, signing off. And I think the other thing I'd want to see is some people telling me that they're going to implement and deploy, because one of the problems with the previous thing has been like people didn't want it. And so I think I just want to know if there are applications where this is going to be used. It's a little hard to fit in the browser context, though maybe we could do it at some point, but that's what I want to hear.
Yeah, Ben K, jumping in again, specifically to clarify, I don't think it's terribly useful to ask people, we just looked at this slideshow, make a decision right now. So I think we should probably take most of this offline, but I'm still happy to hear what Kenny has to say.
Kenny Patterson, thanks for bringing this forward. I think OPAC is a very interesting protocol that's had a lot of formal security analysis. I guess I'm slightly concerned about the integration with TLS 1.3, because now you're bunging it together all kinds of other Diffie-Hellman shares and signatures, and so is there any plans for doing some kind of formal security analysis of this integrated protocol?
None officially, but I'm going to be talking with Hugo about that after this.
Hi, Rich Sauls. It's really cool. You're good. Hugo's really good, but nobody deploys SRP in existing things unless they're on light poles already that have got a 20-year lifetime. So I don't see a need to put this into TLS.
So to echo, this is Richard Barnes from Cisco hat on for this one. So to echo his question about implementation, the reason my name and Owen Friel's name are on this draft is because we've been looking for something of generally this form. You've seen me on the stage before with some earlier PAIC proposals. Like we need some PAIC stuff for some of our low-touch onboarding for devices with limited interfaces. So I think we'd be looking to deploy something like this in this context to help with IoT-like onboarding. Oh, and also on the browser context, I think that's, I think there's some possibilities with the exported authenticator flavor. You could imagine some scenarios if there were interest by web developers in this, in exposing an API that could pipe through to that sort of exported authenticator mode. There's obviously all the standard, web API considerations there, but there's at least a plausible logical connection there, it seems to me.
Martin Thompson, we have some use for this or something like this. Unfortunately, my understanding of how this operates means that it isn't really suitable for the use cases that we had. And they're fairly similar to Richard's one, so I'm not sure that I understand it properly. But I couldn't work out how to make this map onto the sort of use cases that we were talking about. And the similar ones to what I think you're talking about, which is you have low entropy values on devices and you want to be able to bootstrap them up into a security context. One thing, assuming that we can resolve that, then I'm pretty happy with this one, but I didn't see how that would work. Considering that you have an enrollment stage that exists in OPAC that is a little awkward, and honestly, it sort of assumes that you've got a pre-existing relationship that in this context you don't necessarily have. So I'd like to understand what the requirements are for PAICs and how this one would fit into that context a little better. So we should continue. I should come and talk to you and Richard and see what happens there. Is this preempting the CFRG discussions on PAICs?
No, I don't think so.
No,
we'd never pick it before they said yes. So I mean, he's talking about it, and hey, look at it. I think it's
sure. This is more about this is how you would fit it into TLS 1.3.
Hi, this is Hannes. We, together with a couple of other companies, have standardized a password-based authenticated key exchange in Thread, which has been used for IoT device onboarding. We actually brought it to the IETF and was sent away. It's still deployed. It may also be something to look at to see whether that also meets your requirements, because it was developed also after looking at SRP, which had the same issues as you found out. But it's a different scheme. You didn't mention it on the slides. I will send a pointer to the list. There's an expired IETF draft around.
Please do.
Alexei Melnikov, please come tomorrow to CFRG. There would be initial discussion.
comparing them, including OPEC. So bring popcorn, folks. It'll be fun. Well, we might not have enough time for popcorn, but there will be initial discussion.
All right. Thank you very much, Nick.
Oh, you're going to do it. Yeah. All right, cool.
All right, so I'm presenting on behalf of Douglas and Shai, who unfortunately could not be here due to academic and time zone reasons. So because we are very short on time, I'm going to have to hustle through some of this and just kind of focus on the high-level goals. So this is all about hybrid key exchange in TLS 1.3. As you may or may not be aware, there's currently a lot of interest in this area. In particular, there's a number of drafts describing how you might do it with TLS 1.2 and TLS 1.3. There are actual experiments going on, in particular the ones by Google. There are implementations by the Open Quantum Safe project that Douglas is working with. There's even some work in a similar framework of sorts for IKE, as I understand it. And in general, people are trying to build or future-proof the protocol such that if we had a blessed post-quantum or next-generation key exchange algorithm, we could potentially slide it in, and in the meantime, just begin doing experiments alongside existing classical key exchange algorithms. So, of course, the motivation for this is the post-quantum threat, but this is more so focusing on just how would we add multiple key exchange algorithms to TLS 1.3 should we desire to do that. A specific non-goal is to do any kind of algorithm selection or recommendation of any kind of sort, specifically and especially because the NIST competition is still ongoing. The CFRG has not decided that they are going to take on any particular post-quantum key exchange algorithm, I hope that's very, very clear. This is simply just the framework as to how you would extend the existing protocol to incorporate multiple key exchange algorithms. And so there's a couple different design parameters you could go, or axes along which you could potentially slide things in. So for example, you have to answer the question as how you would actually negotiate use of a classical and post-quantum key exchange algorithm. There's the question of how many algorithms in key exchange algorithms you would want to combine. Typically it's just 2, but I don't know, in a crazy world, maybe you want like 10 key exchange algorithms in a particular connection. That might be overkill probably. You have to specify exactly how you would convey the public keys necessary for the key exchange, and importantly, how you would mix the result of the key exchange into the traffic secret and into the key schedule. And in doing this sort of looking at these different design trade-offs, it's important to keep in mind that different aspects of their implication on the protocol itself, its performance, and potential software implementation complexity. So for example, does it introduce any extra round trips? Ideally, no, because that would be probably a non-starter. How much duplicate information is sent in both the client hello and the server hello, or whatever handshake messages are necessary? And how obtrusive is the required changes to the TLS key schedule. Ideally, we want to keep things as simple as possible, both from a software implementation perspective and from a changes to the protocol perspective, such that things like formal analysis just kind of fall out at the bottom. So I'll focus on 2 particular design parameters because the other ones are sort of related, and potentially I can just kind of defer you to the draft to read them. The first is how you would actually negotiate use of a particular classical and post-quantum variant. So you could negotiate them individually. So for example, have 2 separate lists, one that lists all the classical algorithms, one that lists all the post-quantum algorithms. That's probably not great because especially if you're it might be good from a reducing duplicate information if you want to, have a design such that you can mix, one classical algorithm with potentially multiple post-quantum algorithms. You might only, in this case, send 1 post-quantum key share in the client hello. Whereas if you were to have 2 post-quantum algorithms running it in a particular experiment or in a particular connection, you might have to offer up multiple key shares if you were to negotiate them in a combined fashion. But from an implementation perspective, especially with the experiments that are ongoing right now, it's much easier, as was pointed out by the list by Martin and others, to simply negotiate them together such that you offer up a new name group, for example, that says, I am doing curve 259 and whatever fancy post-quantum algorithm you want to negotiate. The key combination issue issue concern is also pretty important. The main requirement is that you want the desired, or the security of the session key to be robust, and by robust we mean that effectively if one of the key exchange algorithms is broken, it reduces to the minimum security level of the combination of the two. So if crypto binomial breaks but the post-quantum is fine, then it reduces the post-quantum algorithm and vice versa. And so there's different ways you could achieve this by mixing in the result of the two key exchange steps into the key schedule, one of which is to simply concatenate the results and shove them into the key schedule as currently done today in the experimental implementations. You could KDF the two or two or more, depending on what you choose for how many algorithms you wish to negotiate. KDF them together and then feed that result into the key schedule. You could even XOR them together. And there are papers that describe the security of sort of abstract abstract models of these particular combiners for chems and specifically chems. And I don't know whether or not that includes Diffie-Hellman-based chems. Probably does. Hugo's or Kenny's shaking his head. So, and the last option is to you could potentially stick it in the 0 slot, which we just heard that potentially could be used for opaque integration and potentially also used for semi-static integration. So, probably don't want to put it there specifically because it's not that has potentially other places where it can be used. Yeah, Ecker.
Yeah, I mean, just in terms of like implementation convenience, I mean, so first of all, I think like pretty clearly, like this is a fake kind of to curve. It's obviously the most easy way to implement it. We know that's what Google did in their last round. So for implementation convenience, if you do that, then clearly you want to follow one of like one of 1, 2, or 3.
Yes.
And it probably doesn't really matter which one of those will like ask a cartographer which one to do. But like yeah, I think like we're much more likely to do it if it looks like that.
Yep, agreed.
Yeah, Martin Thompson, I think someone pointed out on the list that the last one means that you don't get the results of the PQ exchange in the handshake keys. I think that was someone pointed out on the list that was a problem.
I think it depends on where you actually slide it into the key schedule. But yeah.
The 0 at the bottom.
Yeah,
because that's after the handshake keys are derived. So.
Richard. Okay. Yeah, these are the different ways you can do it. There are some more technical questions to address that potentially may or may not be within the scope of this particular draft, depending on where they want to go with it. Specifically with relation to the chems that are being discussed in the NIST and the NIST competition and the possibility of chems being added to TLS 1.3 later. It's unclear whether or not any chem will suffice or whether or not you need certain criteria for the chem. In particular, so if you have CCA secure chems, they are certainly more expensive than CPA secure ones. And there's also chems that have a non-zero probability of failure. So it's unclear how that actually fits into TLS and what you do when you have a chem decryption failure. So maybe the outcome of this effort is that you don't use those particular chems, or you prohibit, maybe make a requirement that TLS must not use things that potentially fail randomly or with some probability. And I guess from a procedural perspective, because there are several efforts floating around both in the IETF and TLS and IKE, there's a question of as to whether or not the working group should be actively working on this sort of thing right now, and in what kind of capacity, whether that means, looking at the different design considerations and just trying to lay them all on the table to evaluate the design space, or to focus on selecting one particular incarnation that, fits best with TLS 1.3, or do nothing and just kind of let the experiments run as they are. Kind of relatedly, a question to the working group is whether or not, as sort of a input or feedback into this competition, whether or not we should work on defining a set of requirements for chems or any other, next generation key exchange algorithm that would be necessary for it to be, applicable to TLS 1.3, particularly going back to the ones that have non-zero probability of decryption failure. So, yeah, Martin.
Yeah, Martin Thompson, I think this is pretty valuable stuff, particularly like the fact that there's been some citations of papers that have done analysis on these things and sort of shown that various approaches to which ones work and which ones don't and all those sorts of things. I would like to see us work on something like this. I would like to see the document say which one we've picked and which one we'll be recommending, having an appendix with the alternatives and some analysis of those and perhaps some explanations of why we thought they were suboptimal would be extra valuable. But ultimately what I want to have is this is the way we're going to do it in TLS, so then we don't have to have that debate for every single PQ thing that comes along.
Agreed.
And when it comes to non-zero probability of failure, no thanks.
Yeah, so just remember, we got to keep this quick. We got about 5 minutes, and we still have 2 presentations. So if you can send it to the list, that would be appreciated.
Very quick then, Jonathan Hoyland, Cloudflare. I think there's quite a few drafts that have come up today, all of which that say we need to define a new way of bringing in a new key into the TLS handshake at some point, and if we had, in the same way that we have exporter keys, we should have an importer key and just have a place for importing keys into the TLS handshake, and that would satisfy the needs of about 3 of the drafts we've seen today.
Hi, Tobias Heider. I find it hard to put them into 2 groups. Like the draft is talking about traditional and next generation ones. Actually, like Macaulay has been around since 1978, and it's also in the NIST competition right now. So what is it, traditional or next generation?
I don't have a particular opinion on that topic. We were just using 2 words to define 2 possible candidates. You could use, for example, P259 and P256 if you wanted to. Like the framework was, what we're trying to get at with the framework is a way to fit in 2 key exchange algorithms, be it 2 classical, 2 next generation, 2 post-quantum, 2 foobar, whatever.
Well, the draft doesn't say that right now. So, but I think that's.
I think they would. I mean, I'm sure they would welcome some clarification around that particular language. I don't think it's their intent to limit this specifically to just classical and next generation. So, or whatever next generation is. Yeah, Kenny.
Kenny Patterson. 2 quick points of information. The decryption failure probabilities for the NIST candidates are all pretty low, like 2 to the minus 40 and lower. So you can just fail the protocol and restart in that case, right? You're more likely to have a TCP error of some kind or something.
Yeah.
And the second one is that the research community, the crypto research community, is still going round in circles trying to figure out what the right way to combine different keying material is. And so it's still very much a live research topic, which suggests it's slightly too early for the TLS working group to be really pinning down details on the right way to combine different key shares. I think the papers you cited are like from the last year or 2.
Yeah.
And we're still developing security proofs, and particularly for quantum adversaries for those kinds of things.
Yeah.
I'd give it a little while to settle down.
The arguments that were given, I don't know if it's actually written in the draft, but the sort of connection was that in the abstract sense that the combiners were proof secure in the papers, for example, Douglas's paper, that the arguments would sort of just carry over to TLS by virtue of the fact that, the key derivation in TLS works a certain way. So for example, in the dual PRF example, they give the naive broken case where you just take the HKDF of, secret share 1 and secret share 2 and use that as the traffic secret, but that doesn't work due to some reason. So their recommendation is to take the PRF of the KDF of key share 1 and 2 in addition to the ciphertext, the chem ciphertext. So, and they say that's fine in TLS because there's this derived secret that includes the transcript and that includes the ciphertext. And
I think the audience for this particular conversation is very small, so we'll talk about it over a beer maybe.
That sounds good.
Thank you.
Thanks, Hannes. You're up. You got about 2 minutes. Luckily, this is a fairly simple.
That's going to be fast. This is about IoT and IoT-related topics. So we are trying to find out how we can optimize the key exchange. One area of investigation we are doing is, besides all the CTLS, etc., is how to shrink the size of the certificates. And this proposal uses CBOR web tokens in TLS instead of the certificates. If you haven't been following CWDs and JWDs, there are a couple of RFCs out there that define the JSON web token, which was originally originated in the OWASP working group as a way to encode access tokens, and was later extended with a so-called a proof of possession extension, which essentially allows to embed a key inside that JSON web token. Not long ago, we then found out that that may be a little bit too heavy for IoT scenarios and used a different encoding based on CBOR, which then turned into the CBOR web token, which is what I'm using here. JWDs are widely used in today for all sorts of identity scenarios and authentication scenarios. There are a set of claims defined in those or carried in those tokens. They are registered in with IANA, so you can look up many of them for the JWD. What is interesting is those tokens work in a somewhat generic fashion. They are using both symmetric as well as asymmetric cryptography in terms of how they are protected or how the claims are protected and or what key is embedded inside. So quite flexible. Here's an example, and this is obviously not the binary encoding, but the diagnostic syntax, and you can see the key, an asymmetric key that is embedded inside. And yeah, so there's some other examples in the previously mentioned documents for symmetric cryptography as well, but I'm not going into those. And the proposal of this draft is to use the certificate types registry, which has been established some time ago, which is also used for the raw public key, and Nick was just recommending it to reuse it for also for these password-based authenticated key exchange as well. And it's used for the raw public key, which is obviously very small, but we found out that that's a little bit too aggressive for some of the deployments because it lacks, obviously intentionally, it doesn't include more than the key, but as you can imagine, for some deployments, that's, or for many deployments, that's not really possible. Picture I stole from Carsten's presentation. If you have been at the SEC dispatch meeting earlier this week, you saw that some people are trying to replicate or profile the CWDs to contain information that you would typically find in certs. Why we wrote this up is because I'm trying to find out whether some of you have also been looking into this and work in the IoT space and want to figure out on what the implications for code size, RAM, over the wire overhead, etc., are. And so if you want to do that, drop me a message. The document is extremely simple. Obviously, it registers the type. But one thing it also does, it talks about how to do the map or the matching between what is found in this CWD, which is, for example, provided by the server side for server-side authentication in the subject claim with the SNI provided by the client side. It focuses only on POP tokens, not like in many of the older OWASP deployments which use bearer tokens. Jim Shad worked on implementation of it over the weekend at the hackathon and found it quite easy to integrate, but he hasn't gotten to the POP usage yet. So drop me an email if you care about this. You're obviously not ready for prime time, an experiment.
Quick question. It seems like some CWTs are certificate-like, the proof of possession ones, but many are not. So I think your last point on the previous slide may have addressed this. Is there a need here to kind of profile down CWT to be appropriate so that only the ones that are certificate-like end up in TLS?
Yeah, that's text are also included in the document, so it's not meant to be used for example, bearer tokens or other things that are not fit for that purpose. I think that would be a security problem.
So we're over time. We'd like to ask for your indulgence. We do have one more presentation, so if you could stick around for another 5 or 6 minutes before you run off to dinner, that'd be great. Dimitri?
Hello. I wanna suggest one more solution to cheat DPI. Speaking about DPI, I mean DPI as a part of censorship of content. Speaking about HTTPS TLS, we have to notice that if those who provide censorship are ready to filter the content by IP address, we can't do with it anything. Other public information is host name present in certificates, which is encrypted when TLS 1.3 is in use. We also indicate host name in SNI, and the encrypted SNI can be suspicious itself and blocked itself. And there was information, but as far as I know, it's not confirmed that there was a censorship based on encrypted SNI usage. And there is a very suspicious idea of this or that whitelisting. We don't block content if we see that host name is in this or that whitelist. So I suggest a way to try to cheat DPI or to make its complete implementation harder. As the standard does not require that SNI should be real, we want that SNI should allow to determine which host name we want to access. We call this name true host name, and fake name can be a synonym published in for example, in DNS, so the client sends fake SNI in its SNI extension. It goes in clear text. Then when TLS 1.3 is in use, we get a normal handshake. And this solution seems more or less reasonable fallback when encrypted SNI is censored itself. Of course, it's possible not to deal with fake SNI. It's possible to register domain names, but as a fake SNI can go for free, and in most cases you have to pay for registering domain. The time to live of fake SNI can be relatively small if it is delivered via DNS, and it's not a problem to implement fake SNI based solution in code, neither in server code nor in client code. So the idea is the simplest idea is we just publish in special record a fake SNI that allows to implement the real host name, and server responds with a certificate containing real host name, but as it's encrypted, it's unfiltered. Maybe it's possible to generate some rule of rule providing to generate some fake names. Maybe it makes sense to use one-time fake name, though it can be very expensive. And maybe we can issue sub-certificates, but it seems a more difficult solution. Here is the link to the draft itself and to GitHub. If anybody is interested, feel free to contact me. Thank you.
Christian Wiedemer. Dmitry, we did a draft
putting up requirements and known attacks against various SNI encryption methods. Have you run your solution against this list of attacks?
Sorry?
The current draft, I mean TLS SNI and TLS
Fake SNI, yeah?
Yes.
Yeah.
As a list, not the ESNI solution, the SNI requirements, as a list of attacks there that are known against various SNI obfuscation or encryption systems. And I'm asking whether you have done that or you plan to do that and check your proposed solution against this list of attacks.
Okay, I will.
Yeah.
Thank you. I will check. Thank you.
Because in particular, I think that you have an issue with replay attacks and discoveries and things like that.
Okay, thank you very much. Good point.
Roloff Toy. So 2 comments. The first one is, I think you're wasting your time because the devices that do this can do the same thing. They can have a database. So you're just moving the arms race slightly forward, and you're wasting your time. The second comment is that censorship is not always bad. I have children and I have parental guidance software. So that kind of censorship should not be avoided by this mechanism.
Well, I will leave the second comment without reply. Regarding the first comment, the proposed solution is very cheap for a client, relatively cheap for a server, and being used widely, it can be very expensive for a centralized censorship mechanism.
Eric Nygren, I think like the ESNI, I think the big challenge with this is going to be configurability, especially you're not going to want to have people having to do yet another DNS lookup ahead of this, and a lot of the ESNI type issues in terms of DNS records not being aligned together are going to also show up as challenges. There are cases, we've talked about this in this past, where combined with other things this could be useful, like if this was an attribute of the ESNI keys record, or there's a draft somewhere for a alt service SNI attribute, which covers this use case and talks a bunch of this, which could also be useful. The one case that became very useful there in the discussions and on that matrix was to be able to indicate that when you have a wildcard cert that you're going to be going against, to be able to specify something like wildcard.example.com rather than the full SNI one, just because that's a fairly easy win. If there's a way to provision it, it's just provisioning it's hard.
Maybe.
All right. Well, thank you very much, Dimitri, and thank you all for staying over time.
Thank you.
Thanks. Let's go forth in TLS. We gotta make some T-shirts again.
Yeah.
I don't know. I'm gonna have to come up with one.